Hello, I'm John Saunders, and I'm here today to give you a demonstration of an attack on a mock pipeline system that's working through an actual programmable logic controller. What you see here is our human-machine interface, or HMI, that actually controls a couple of mock compressors on a pipeline. So let's go over and look at our system. The box that you see on the bottom there is a programmable logic controller. It accepts the commands from our HMI and actually triggers the electricity that would turn the compressors on and off. So I'm going to turn our second compressor on. Now, in a particular situation like this, the pressure could conceivably build up in this pipeline because the first compressor is not working, and even conceivably have the line burst. So let's go ahead and click the first compressor on. So now we have smooth flow through our pipeline. I'm going to turn them back off here and talk about how the attack would work. What we're going to do is substitute this good code for some malware that we have programmed. We're going to do this through a USB attack. By inserting this particular type of USB into our system, it will automatically run some software that we've installed on this USB, and I'll explain more about that later. Alright, now notice we have our good code up here. Disappears. And then we have the HMI come up again. Now, perhaps an operator would think this was funny. Often the operators aren't even looking at the screen. These are 24/7 systems, and so the tendency is to not watch them all the time. So the operator would see this and say, oh, well, okay, I guess I need to turn on our system. And so I'm going to go ahead and click compressor 1 on. Okay, so you see that compressor 1 is on, but what does the HMI say? Well, it says that it's off. Keep in mind that the operators for these may in fact be hundreds of miles away and totally unaware that in fact the system is on because their user interface says that it's off. Let's pan over to the system, and I'm going to click on compressor 2. Notice that it goes on, goes off, and comes back on again. Whereas you may not think this is not a particularly big deal. In fact, by doing that, what you're doing is you're actually stressing the system, and we've coded into the malware just a simple one-time on and off. In fact, we could have coded something in where it's constantly turning on and off, again, just to stress the system. So let's take a look in a little more detail of what happened. This was the content of the auto-run USB drive, where we took and we copied the bad code onto the system. We killed the process that was running in the memory, and then we restarted the bad code. This is the code itself. Basically, it reads the status of the system. If the pump is on, it turns it off. If it's off, it turns it on. This is the false information, where what we've done is basically said, okay, indicate to the operator if the pump is off that it's on, indicate to them if it's on that it's off. And then here is the disguising on compressor 2, where we basically just put together a loop that turns it on, runs it for a while, turns it off, and then turns it back on again. Again, the whole point is to stress the system. So hopefully we've given you a little insight into how an attack on a programmable logic controller in a control system would occur. Thank you.